So we will be looking into the brief of working of electric vehicles, starting from the vehicle dynamics and going up till the battery management systems. And so we will give you a brief introduction. It won't be a technical. If you are looking for a technical, very technical oriented course, this is probably not the course for you because this is a very introductory course. And then we will look into the electric drive powertrains, and finally we'll discuss few of the components of electric vehicles. Now, coming to the introduction, we all know that our life is almost from the time we were born. We have seen IC engines based automobiles, but as we all are aware that pollution is a concern, so we had to come up with alternative uh, vehicles or alternative mode of engines for powering the vehicles. So from then we started with hybrid electric, and then we went into battery electric vehicles. So the first was almost parallelly like hybrid electric, battery electric, but hybrid electric gained a little bit more uh, at attraction due to the Toyota Prius model first. That was the time when hybrid electric vehicle started gaining attraction. So it gained attraction as a popularity as a cleaner and greener means of transport, and which would reduce, at least claim to reduce the pollution, so that we can live in a greener earth. So coming to the block diagram, we normally define any system or any engineering system in electrical or mechanical engineering as a block diagram. We try to look at the different parts of the components as a block diagram. So if I start from the so if you look at the diagram, I have um, bordered a red line throughout. This is to show you that this part of the diagram is mostly uh, electrical, and this is the mechanical, electromechanical coupling happening here, and the wheels. So three of the major components of any electric vehicle drivetrain are the traction motors. This can be we have all kinds of traction motors right now in the market, from starting from induction motors, permanent magnet motors, and permanent magnet also has BLDC. You might have heard of BLDC, BLAC motors, and also we are looking into synchronous reluctance and also switch reluctance motors to reduce the use of permanent magnets. So that is the major part of any electric vehicle propulsion system is the traction motor, which gives us the necessary traction force so that it can overcome something we call as a road resistance or a road load, and necessary velocity and acceleration. So that is the uh, role of a traction motor. Now, traction motors are mostly can be a single phase motor. It is mostly a three-phase motor. Uh, so and the power comes from the battery, which is placed in, underneath the passenger seats, underneath between the chassis and the passenger seat. In most vehicles, some have in the front where the engine was supposed to be. Some have front and back align placements of batteries. So batteries are inherently DC devices, DC powers supply. So we have to have a converter which converts DC to AC to be supplied into the traction motor. So that's where the power electronics comes in. Now, even for a even for a DC, let's say we have a DC, brushed DC, one of the most which is not that much used, but let's say, but still we need to have a power electronics so that it can convert the DC with the it can regulate the DC. So we have something called a DC chopper, DC to DC chopper. So power electronics is also a major part of a electric vehicle drivetrain. And of course, the batteries and the battery management system, which without which there is no fuel to our traction motors. So batteries essentially act as a fuel if you compare it with the IC engines. So and a very sophisticated and regulated battery management system is very essential for a good operation of an electric vehicle. So if you do a cost analysis of the whole components of electric vehicles, you will find that most of the companies, most of the cars will have a very sophisticated battery management system. It is a computer which does all the takes inputs, takes from the sensors, calculates, runs algorithms so that it can operate its battery at the highest um, possible performance so that it can extend its life, extend the life of the battery, extend the range of the vehicle, and all these things. So battery management system is almost the brain of the, if you would like to say that, it is the brain of the vehicle. Also, all these things, the battery management system, the power electronics control, and also the traction control, we can club it into something called a control system. Now, and they have outputs for the control signals from the traction motor, like we have, let's say, MTPA, which is a type of control, also flux weakening. If you are have like if you are introduced to flux weakening terms, then you are quite ahead in your electric vehicle journey. So these control systems, uh, these are the algorithms that we mostly work with when it comes to a. We have here our speed and position sensors, and also we have current sensors. From here, we have current sensors into the. So mostly we need to look at the current and the speed or the position of the mostly speed. Position is not needed for like for electric vehicle. Mostly we look at speeds, but if it was, let's say, a servo, or we would look at the position sensing as well. So uh, also there are newer technologies. If you are interested, there are newer technologies which try to we have control algorithms which don't need the inputs from here, which are the speed and position sensors, because if you go a little bit uh, in depth of the sensors and the type how it works, you'll find that there are number of problems when it comes to the sensors, the wear and tears, the inaccuracy of sensors. So we are looking into sensorless controls, uh, like something which has been around but wasn't used that much. It's a DTC called a direct torque control, and that type of controls are inherently sensorless. So and also we are looking into actual sensorless controls as well, so that we can only measure our currents, and that would be enough to control our motor. Now, there are, of course, there are some demerits to use of sensorless controls, but we are looking into it so that we can reduce. the wear and tear of the components, and to give us a better response in high speed drives. These are all high speed drives. Most all the electric vehicles will use high speed drives, and so hence we need to have a sensorless control. If we have a sensorless control, we need to have a response of the sensorless control, which is very apt and very accurate, so that we don't lose our edge uh, when it comes to the sensors. Now, this is the diagram that we are talking about is a complete battery electric vehicle. It is also called BEV, or sometimes plug. EVs are generally, if we are talking about EVs, we more often than not think about battery electric vehicles. There is another which we are talking about, hybrid electric vehicles. We will look into it a little bit details about the various topologies of hybrid electric vehicles. But the only difference is that it has a IC engine along with, so it will have all these components that we have discussed, but it will also have a uh, uh, it will also have a IC engines and also generators and uh, some other components as well. So again, there are topologies of hybrid electric vehicles: series parallel, hybrid. So every topology is designed to give us some benefits, and uh, so we will go into it once I go through the lectures, and we'll see that. Now, how does an electric car run? It is a basic explanation would be an electric car is run by a motor powered by a battery that has been charged by a external source. So if this is the external source, we can charge the battery, and that battery in turns will go through the power electronic, convert it into AC or DC, depending upon what is your traction motor, and that will be uh, giving the power necessary propulsion to your vehicle. Um, EVs can convert about 59 to 62 of the electrical energy from the grid to the power. So if I take from the grid, let's say this is connected to my grid. From here till wheel, if I take this journey, we can have a 59 to 62%. Although if I don't take the grid, only take the batteries and the power electronics, they have a quite a high efficiency, and uh, even permanent magnet synchronous machines are used for that reason, that they can deliver a good efficiency. And of course, the power electronic switches are traditionally thought of as a very almost like an ideal switch. So there are no switching losses. That is assumed, but of course there are switching losses, and there are resistive losses, and we need to cool it. We need to have a cooling mechanism for my battery, for my power electronics, for my motor. Everything needs to be cooled. But so hence there will be some losses uh, as heat, or we call it as electromagnetic losses as well. So if we look at the future of electric vehicles, uh, we we can talk about technologies like V2G, which is the battery inside the vehicle can be thought of as a power source or a energy storage system, because that uh, to give you an idea about a battery typical Tesla. Let's think about a Tesla battery for a second. So if you think about it, that Tesla battery, a normal household of your any household uh, can be powered solely from a single charge of a Tesla battery for around 5 to 7 days. So that is how much energy is stored in a fully charged electric vehicle. So that is a good. So we are looking at V2G technologies powering our homes uh, with our electric vehicle batteries, and also we can talk about the second life of electric vehicle batteries, because electric vehicle batteries are once the performance of the battery degrades over time. There are measures which calculate the performance of the battery, like let's say state of health. We can talk about that. What is the state of health, state of charge, a little bit once we go into that details. But let's say there is a performance parameter called state of health, and once every manufacturer recommends that once the battery goes below 80% of state of health or 70% of state of health, it is unsuitable to be used as an electric vehicle battery. But this is perfectly fine to use as a solar PV batteries, and also any standalone energy storage systems. So that is what we can use it for futures. There are number of companies who will take your electric vehicle batteries and use it for power voltaics, solar PVs, batteries as well. And coming to the other futures of electric vehicle, we can plan that the states and utilities to build an infrastructure so that uh, the charging of electric vehicles can be fit we can fit in, because uh, whether you like it or not, charging an electric vehicle will take a lot of uh, electric energy from the grid. It is a huge load when it compares. uh, you need to be equipped, or your grid needs to be equipped to handle the load. If let's say we have 10 houses in a colony, and let's say initially there was no electric vehicle, but now let's say 5 or 6 electric vehicles. So mostly people will work from, let's say from 10 they go off to the office, comes back around 7 7:30 and puts their electric vehicle, like you put your phone into your charger. So similarly, most of the people will charge at the same time throughout the night. So you need to have certain algorithms or optimization techniques so that you can handle that load, sudden increase in load in your power grids. And also, if without a cert, uh, apt renewable solution, if you uh, don't have a renewable, let's say solar or wind in your grid, in your utility grid, it will ultimately be taken from a fossil fuel run thermal power plants or gas power plants. So ultimately, we are increasing the pollution. Maybe not directly, maybe indirectly, and maybe to a lesser extent, a far, far, far lesser extent than a IC engine, which causes the pollution. But we are uh, adding to the problem rather than solving it. So future should be electric vehicle as well as the grid to be able to handle that load. That is how a future of electric vehicle or electric vehicle, uh, let's say electric vehicle environment can work. So when you think about electric vehicle technology, you should think about this part as well, from the grid to the charging station, not only this part. So coming to the types of electric vehicles, and so this will be the last slide for this lecture. We'll have a 5 minutes. I'll go through your questions quick. So types of EVs, mostly broadly, it can be classified into hybrid electric vehicles, battery electric vehicles, and plug-in hybrid electric vehicles. Uh, these are both run by gasoline and electricity depending upon the commuting distance. There are configurations, as I was talking about, the series and the parallel hybrid electric vehicles. So, depending upon the configuration, it decides when it should run in electricity, when it should run in gasoline. However, the battery electric vehicles are completely and fully electric vehicles in a true sense that it has no IC engines, no petrol, no diesel, and no fuel tank, and no exhaust pipe. So this is a truly greener technology in the true sense, but battery electric vehicles have problems when it comes to long commutes. Uh, there have been surveys where people with long commutes would prefer using hybrid electric vehicles rather than battery electric vehicles because of the same because of the reason that they are they are uncertain about the charging infrastructure of a country, especially countries like ours where there hasn't been a charging infrastructure as there are petrol pumps everywhere. There hasn't been such a boost of till now there hasn't been such a boost of electric charging stations. So that is why people would still prefer a hybrid electric vehicles. Now, plug-in hybrid electric vehicles are also called extended range electric vehicles. So they are again similar to hybrid electric vehicles that they are powered by both petrol and electricity, but they are uh, they are mostly used to extend the range of a vehicle. It is like uh, let's say uh, a help or so can recharge the battery through both regenerative braking and plugging into a external. So this has capability of regenerative braking. Also, electric vehicles in general has a very good property of regenerative braking, which if we can harvest it with proper control, can be very good at extending the range. And because we talk about range so much in when it comes to electric vehicles, because uh, every user of electric vehicles, or at least people who live in a remote place, would tell you that they are anxious about how long will their charge last, how long can they go, how long can they go in a single charge. So that is something which is very prominent inside the users of electric vehicles. So that is why we always try to extend the range. Any uh, optimization techniques should of your components are focused towards increasing the range of the vehicle, increasing the and fast charging so that we can get uh, same performance as a fuel IC engines. So that's about today's lecture, and I'll just go through few of the questions if there is any. Okay, okay, perfect. I don't seem to have any questions. So we'll again meet tomorrow. And if you have any questions, there is a WhatsApp group. I hope everyone has been like is a member of that group. You can post your questions and any feedback, anything. I'll be happy to answer. Thank you and have a nice day. Bye.